Project 1.6, the synthesizer with 10-tone sequencer.
It's the one hanging off your chipset.
There are three main aspects to this circuit: the clock signal, the decade counter, and the tone generator. The first section is the clock signal. The clock signal is generated through a 555 timer, configured as an astable multivibrator that produces a square wave. The three main pins used to create the square wave is the output pin, the trigger pin, and the threshold pin. The trigger pin is an input that initiates the timing cycle when its voltage drops below 1/3 of the supply voltage, or VCC. This causes the output, or pin 3, to go high, starting the timing sequence. The threshold pin is connected to the non-inverting input of an internal comparator. When the voltage of this pin rises above 2/3 of VCC, it resets the internal flip-flop, causing the output to go low and ending the timing cycle. Through this continuous switching of states, this allows the output pin to oscillate. The next section is the decade counter. The decade counter is very simple. It takes the inputting clock signal and it divides it between 10 pins. These 10 output pins, labeled 0 to 9, each give an output in order. So when 1 will be high, none of the others will be high. Then 2, 3, and so on. Each of these 10 pins are connected to both a diode and a specific resistor. The resistance value of these resistors is directly related to the tone generation in the finished product. After the first two sections, there is a single wire that will cycle between multiple different voltage values. Lastly, the tone generator. The third and final section is very similar to the first section. It's also a 555 timer configured as an astable multivibrator that produces a square wave. However, the wire that produces the multiple different voltages will be added to the control voltage pin of this 555 timer. The control voltage pin is used to set the threshold voltage for the threshold pin. This is useful for adjusting the circuit's frequency without changing the values of R1 and C1. Oftentimes, to prevent noise from affecting the frequency, this pin may be connected to ground. Effectively, this pin changes the threshold voltage, which is usually 2/3 VCC for the threshold pin. Because this pin allows for changes in frequency without changing the values of R1 and C1, this is perfect for making the buzzer cycle through multiple tones.